Awesome. Hey everyone, my name is Tina Sepahpur. I am the water level project manager here at MARACOOS. I appreciate you guys being here today. Before we get into the Delaware specific work, I wanted to give you a quick overview of the broader regional effort that is going on here in the Mid-Atlantic. So to start off, um, coastal communities in the mid-Atlantic are facing more frequent and severe flooding. This can be anything from sunny day tidal flooding to storm surge and compound events, which is harder for local officials and planners to respond to effectively. This can be anything. One of the things that we hear over and over again is that we need better real-time data and more collaboration across states. And this project is helping make that happen through sensor deployments and hydrodynamic modeling. So we call this the Waves Water Level and Webcam project, or the 3Ws for short. Well, this is part of a broader national effort led by IUs. Today we're highlighting the work here happening in the Mid-Atlantic. So this project is a collaborative effort across 5 states supported by the Inflation Reduction Act that's helping communities across the coastal communities access the data that they need to better prepare for flooding and building long-term readiness. This effort includes deploying low-cost water level sensors, wave buoys, ADCPs, webcams, and building hydrodynamic models to better track and forecast coastal flooding. The data we collect feeds directly into tools used by emergency managers and planners, which helps communities better prepare for things like storm surge, sunny day flooding, and wave impacts. So one of our goals is to make sure this data doesn't stay just local. We're working to align it with national standards so it can be used in federal platforms like co-ops and eventually feed into NOAA National Weather Service tools. Ultimately, these efforts improve real-time awareness and support long-term resilience planning across the region. So we've been working with the weather forecast offices to improve local modeling and forecasts by sharing the data we're collecting through this network. But this isn't just about pushing out the data. A big part of this is building that two-way conversation with communities. So we want to hear from you and know what kind of data would be most useful in your day-to-day work or planning. And really, this first year is about listening and learning. Where are the gaps? What's missing that would help you plan or respond to flooding better? And we're also making sure that we're including a wide range of voices. So we're doing this by connecting with tribal, local, and regional partners because each community has different needs and priorities. We have a customizable data platform called Oceans Map that Sherry will talk more about shortly. But we want to know, what would you like to see on it? And what would be most useful to you and your team? Again, this is a collaborative effort, and the input we get from you directly shapes the tools we're building that would be most helpful for you and your communities. So we are partnering with the University of Delaware, University of Maryland, Stevens Institute of Technology, Monmouth University, and Virginia Institute of Marine Science to enhance monitoring across the Mid-Atlantic. So although each state is tailoring their approach to meet local needs, in the end, we're all sharing common goals, such as improving flood forecasting and early warning, supporting community readiness and adaptation, and integrating this data into national and regional tools such as Oceans Map. Now that I've given you a bit of an overview, as a whole, I'm going to briefly talk about what our other partners are doing in other states. So first up is University of Maryland. This project is run by Dr. Tim Canty. So this project is part of the university's HydroNet and Climate Resilience Network that builds on UMD's Grand Challenges work that really started as a pilot program testing sensors in Annapolis and talking to local partners around Maryland. The goal is to expand a low-cost water level sensor network in Maryland and around the Chesapeake Bay. So they are focused on data deserts, which are areas along the Chesapeake Bay that don't really have any real-time sensors of any kind, better yet, water level sensors. So they have currently deployed 12 Hohonu sensors on the eastern shore and are currently looking at other sensors to deploy throughout other parts of Maryland. There is still ongoing engagement to determine locations with the highest needs for these sensors. Next up is a partnership between Stevens Institute of Technology and Monmouth University. So this project is run by Dr. Philip Orton, Dr. Laura Kerr, and Dr. Tom Harrington. The goal of this project is to create a higher resolution shallow water barrier estuary model to improve water level predictions. So there has been regional planning in the state, but there's still several flooding issues that persist, like nuisance flooding and sunny day high tide flooding, especially in low-lying areas in the barrier island. And so they're going to be doing some focused data collection, both over land and in water, by using a SOFAR buoy, ADCP, and water level sensors. So they want to see if the SOFAR buoy works well in back bay areas that have shorter periods and smaller waves. They'll be working with the community to identify which locations are best suited for water level sensors to meet the community's needs. And along with this, they'll be utilizing data collection apps like MyCoast, where they can collect photos with time and location stamps to see where flooding is happening. So this will also help verify flooding close to tide gauges or even an area that there isn't a tide gauge close by. And not only that, it will also help verify their flood model, which they hope will help create accurate forecasts using the Stevens Flood Advisory System. And last but not least, we have the Virginia Institute of Marine Science. This project is led by Dr. Derek Loftus. And this part of the project is focused on the southern Chesapeake Bay, especially around Hampton Roads and surrounding rural areas. So they're looking at areas that are dealing with regular flooding, but don't usually have enough water level sensors in place to monitor it effectively. So a big focus on supporting is on supporting rural coastal communities that fall between the more urban population centers. These communities often don't have the resources to install or maintain sensors on their own. So this is a huge help for filling in those gaps. So every year, the team is going to be focusing on different parts of the coast. So we have the Middle Peninsula, Hampton Roads, Eastern Shore, Northern Neck, and James River. And they're going to be deploying two types of sensors. So it's going to be the ultrasonic sensors and the K-band radar sensors. They're also going to be collaborating with USGS during years 2 and 5 to deploy AI machine learning cameras that can estimate water levels by analyzing videos. So all this data they get feeds into a tool called Tide Watch, which is a 36-hour storm tide forecast model that helps validate and predict where flooding is likely to occur. And since some of these areas don't have sensors yet, they're bringing that community science side by encouraging people to report local flooding through mobile apps. This kind of input will help decide where those new sensors should go, especially in spots where both the model and residents can confirm that flooding is happening. So in total, they're planning to install around 20 water level sensors across coastal Virginia over the next few years. And again, these exact locations are being prioritized based on flood risk, data gaps, and community input. And then again, to wrap things up, this regional network of sensors combined with Oceans Map is giving communities the tools they need to understand and respond to coastal changes. We're really proud of this work across the Mid-Atlantic. We've got great partners that we're working with, and we're really excited to see what happens in the next 5 years.